room up there.
What?
Yes, you do it on back. Sure, you can do it in back, that's fine. Okay, sorry. You guys aren't small. You
I'm
can
doing
make
it
it
on
there.
page 20.
Oh, Chelsea, you can't write small.
No, I'm like, no, that doesn't work. But I don't want to do it on page 21. Are we getting page 21 back?
Yeah, oh yeah.
Okay.
Just find a spot for it.
No, I just had meant to break down the page.
Okay.
This game's like she's insane.
Sorry, yes, you're right, long division is vertical, but
Yeah.
I think you could fit it up there. But that's okay. Alright, so when you're dividing, the part underneath is the dividend, the part outside is the divisor. That's what you're dividing with. That's what you're trying to take and break the dividend down into a smaller number. How do you start using long division? Chelsea, who writes too big and can't fit it in the margin.
You start at the very right side. Like the closest.
Like the left.
The. No, it's right.
What do you mean?
Wait, never mind.
Okay.
Why did I just think this is my? I literally thought this is my right.
Well, it happens sometimes.
Yeah, apparently.
So,
You
how
start
would
at the front.
Okay.
Remember.
So what would you do?
Well, 82.
All right, so you start at 82
Yeah.
because there are 2 digits here, and we're going to try and divide our 2 digits into it. And then what do you ask yourself?
How many times can go in? Which is 3 times.
There you go. All right, so how many times can 21 go into 82? Because 21 can't go into 8. 8's too small, so that's why you have to move to the second digit. And that's 3 times. So that goes above the 2, and then you multiply. So 21 times 3 is 63. And then what do you do with 82 and 63, Brandon?
You subtract them.
You subtract them and you get
19.
19. Good. All right. So now the next step would be to pull down the next number. Because 21 can't go into 19. If it can, then you divide it. You didn't use a big enough number on the top. Divide it incorrectly. And then you start the process again. So, Libby, do you know how many times 21 goes into 193?
I want to say 9.
Sounds pretty good. So 9 times 21 is 189. Okay, then we subtract again, and we get 4. And then you bring down the 5. This is a little easier. 21 goes into 45 2 times. So that gives us 42. Subtract, you get 3. Bring down the 4. 21 goes into 34 once. With a remainder of 13. So when you first learned division and you learned about remainders, you would just write that little r. And then you learned that a remainder is actually a remaining fraction of what we divided by. So then we would have written it like 13 out of 21. So your solution would be 3,921 and 13/21. And then after that, you ended up, does anybody remember what you did after that? So like if it said completely divide, Libby?
You do in the decimal.
That's when you make the decimal. Yep. You add a 0, you see if it works. If not, you add another 0, and like you keep dividing until you can't divide anymore. So today we are also going to divide using long division in polynomials. So no. I mean, I guess mine took up like 2.5 feet of space, so maybe that's true. And we are going to look at a graph first to try and see, like, so that you can understand how it fits to a graph and how the division works and kind of how they go hand in hand together. So we're going to use a calculator once, and we're using that calculator just so that we can see the graph and find the zeros. So in your packet, if you look at page 23, our goal in this section is to find all of the real zeros of any polynomial function. And we're going to learn 3 different ways to do that. So we're going to talk about long division, a shorter division, and then we'll talk about some kind of test that can help us kind of pull it all together. So we'll just talk about the long division today, and then next week we'll talk about the others. But if you can graph this in your calculator, just like you did yesterday, like on the last 2 problems of the homework, you're finding the zeros. Find the x-intercepts. Find the solutions, whichever one of those words works best for you. If the power is 3, at most there could be 3. So plug this guy in your calculator. And when you do that, this is what you get. So hopefully your picture looks very similar. How many zeros does there appear to be in the problem or in the calculator? 2. It kind of looks like there's only 2. Because it looks like the max here is on the left and it's kind of just blending into the x-axis. So I suggest if that happens for you to zoom in to get a better view of the picture, and zooming in kind of helps a little bit. Maybe try zooming in again. I don't know. Maybe it'll make it look a little better. Sometimes it does, sometimes it doesn't. Okay, so we gotta get at least a little bit over here. So what I'm gonna do is, zoom 6 is like the fix it for all. I'm gonna go back and zoom 6. And then zoom in 1 time. Zooming in and out all this time. Lots of zooming in and out. Okay, and then I'm going to zoom in a second time again, but I want to show you how zoom in can help. If you move your value over to get closer to the area that you want to focus on, so I just moved my little arrow cursor, the cursor to the left, or to the right. Now look, Chelsea, I don't know my left and right either.
It's about that.
It is. And then hit enter. It'll zoom in closer to that value. So zooming in is kind of beneficial because you can really focus in on a part of the graph. So now we're looking and you can see that it has 1, 2 x-intercepts that are before the value of 1. So do your second trace. We're finding the 0. And if you type the 0 and 1, just like we did yesterday, mine doesn't want to work. Anybody else's work? Oh. Okay. 0 and anybody work with 1? Yes? No? I don't know why mine isn't working. Trying to think. Maybe I'll do 0.5 and 1. Nope. Okay, well my calculator doesn't like me today. See if you can get your calculator to work. See, doesn't like me. Doesn't like Mrs. K today. I do have a picture of I made sure to draw a picture as well. Michael, what did one of your points, because you said yours worked, what did it give you?
I had 2/3 and 0.
Yeah, 2/3 and 0. Anybody else get that? Yes? Some of you did. Okay. There is another one there, and to get that other one, so this one here is the 2/3 and 0. To find the other one, you'll have to use from 0 to like something a little less than 2/3, so maybe 0.6. Because there's a second one. Did you get another one, Chelsea?
I got 0.5.
Yeah. So 1/2 and 0. So for some reason the calculator gives you 1, but I guess because there's 2 there that are so close. So there's another one at 1/2. And then by looking at my picture, where if you zoom out, you can find the third one, and that one would be a 2. Those 2 that are next to each other are pretty tricky though when they're that close together. Any questions? So our goal today is to kind of figure out how this graph and the zeros can be found algebraically. So a little reminder, first on the right side here about zeros. If you have a 0, we can write it in x equals form. But any 0 can be also written as a factor, just by moving the number next to x. So we could write this as x minus 2, that would be a factor. X minus a half could be a factor. X minus 2/3 could be a factor. So that's like a factor, an x-intercept, a 0, a solution. They all mean the same thing, but a factor can be written in parentheses. That factor can become a divisor. So we can take this factor and try and divide with it to try and break a problem down. So on the left side, the divisor is what you divide with. That's what I'm trying to break down. So in our little problem of numbers, it was 21. That was our divisor. The dividend is the big piece, the big number. Your original problem, that's the part we're trying to break down. So the big thing we want to break down is the dividend. The divisor is what we're using to break that value down. And then the answer to a division problem is called the quotient. So just a reminder of what those words are, because you might see them. When we write our answers, we're going to write them in a specific format. So we are going to start always with f of x. F of x is the original function you're starting with. So it's the divisor, or the dividend, or whatever function you're starting with. But we would never write that whole function out. You would just write f of x, because that means whatever we started with. That'll be equal to the divisor times the quotient. So we'll be writing those in parentheses, quantities together. And then if there's a remainder, that remainder is the extra addition or subtraction that gets left beside. Because with polynomials, or with numbers, you should be able to multiply them together, combine your like terms to go back with what you started with. So these are equivalent statements. It just shows you how we're going to be breaking it down and writing our answer. So the divisor times the quotient plus the remainder will be equal to our original function. So we're going to see if we can start dividing. I tried to set this up like so that you have a visual to look at, but in those boxes is where like numbers are going to fall. We have our function 6x cubed minus 16 or 19x squared plus 16x minus 4. That is the same function you just plugged into your calculator. So we're going to try and divide with that function. We're dividing that by x minus 2. We found that x minus 2 as a 0 on your calculator. So this was a 0. Now it's written in factor form. That's going to become our divisor. So we're going to put that outside. So make yourself a nice big division bar. And then underneath, we have the 6x cubed, 19x squared, and so on. So with division of polynomials, your goal is to cancel the first term, and only one term at a time. We can't cancel multiple terms at the same time. So same thing with numbers, like you always start on the left. You start on the number that's in the front. Your goal is to try and get rid of that first number. So we're going to try and eliminate 6x cubed. Since we're only eliminating one thing at a time, to do that, we're going to just look at the x. Pretend the negative 2 isn't there. It has nothing to do with helping us eliminate 6x cubed because it doesn't really have an x in it to begin with. So the question you need to ask yourself, if you have an x, what would you need to multiply it by to make it 6x cubed? Because our goal is to get that to eliminate, so I need the same quantity there. So Virginia, we have an x, what do we need to multiply it by to make it 6x cubed? 6x squared. So that 6x squared goes above the x squared term in your quotient area. So make sure your powers are lining up because like terms of polynomials are the ones that we can add, combine together. So then usually you take the number on top and you multiply it by whatever's in front. Well, we're going to do that same thing. We're going to take that value on top and multiply it by our divisor. But the divisor now isn't just a number, it's that quantity x minus 2. So the minus 2 is part of that. That's when we're going to use to kind of multiply through. You might need to write this on the side for a little bit until you just get used to the process. So we're taking 6x squared times x. There's our 6x cubed, so they're the same. 6x squared times negative 2 is negative 12x squared. So that's how we get those pieces that go underneath. Okay? multiply, just like the numbers we multiply. And then what do you think we do with these? Subtract. So that part's the same as well. But when you subtract a polynomial with multiple parts, that minus sign has to distribute through the whole parenthesis. So it's a minus 6x cubed, but it's also a minus 12x squared. And that negative 12x squared turns into a positive because you're subtracting a negative. So the signs, being careful with the addition and the subtraction signs are so important. And then you subtract. So 6x cubed minus 6x cubed, that eliminates, that's the goal. And then negative 19x squared plus 12x squared is negative 7x squared. So just be careful because it's minus negative 12. Really, that turns into a plus 12. And then what did you do before? After you divided the first step, then what? Chelsea? Bring the next number down. So plus 16x, and then you divide again. So we're trying to eliminate negative 7x squared. Again, ignore the negative 2. It's just the first term we're looking at. Libby, we have an x. We want to make it negative 7x squared.
Make it, or multiply times negative 7x.
Perfect. So negative 7x. So now we're taking negative 7x times x minus 2. The number on top, in this case our term on top, times our divisor. And subtract again. So multiply, subtract. Be careful when you subtract. So you have a minus negative 7, that turns into a plus. We have a negative 14, so that turns into a minus sign. I just kind of changed my signs in the middle so I can quickly look down. So negative 7x squared plus 7x squared goes away. 16x minus 14x is 2x. And then we bring down again. And we get a minus 4. So one last time, Virginia, we have an x. We want to make it a 2x. So we would multiply it by 2. What's 2 times x minus 2, Virginia? Yep. What's the remainder? 0. So when you subtract these, you get a remainder of 0. Questions? You just done your first long division problem in algebra. Well done. So we're going to try and write the answer yet because we're not going to just leave it like that on the top of the problem. Somewhere down here. There we go. Now that I have all these little dots. So our answer starts with f of x, the original function that we started with, we're not writing that whole big thing out, is equal to the divisor, that was what we divided with, x minus 2, times the quotient, 6x squared minus 7x plus 2. And then if there were a remainder, we'd put it back there. So dividing is another way of, my favorite F word, factor. We could then factor this, because it does factor, to get the zeros that we found from the calculator. So it wasn't factorable to begin with, no way to factor that, but by using long division, we pulled out one of the factors. What's left can be factored further. It's factorable. Brandon?
This also works on a calculator, right?
Well, we found those zeros. I mean, we found them in the
With
calculator.
the long division, it works on the calculator, right?
What do you mean?
Can we plug all that, can we plug, your 6x cubed minus 19x squared plus 16x minus 4 divided by 2?
No. You will not.
No, we'll do that.
No. It's not that magical. Sorry. Yeah. Alright, so if you flip the page, we're going to try it a second time with the same exact function. So the goal is to use the same function another time to get you a little more comfortable with the dividing. We're just going to divide with something different. So at the top of your page, it says, is x plus 1 a factor of 6x cubed minus 19x squared plus 16x minus 4? And then it says y. Or it should say y or y not. Be proper. So whatever you're dividing goes underneath. We're trying to break this 6x cubed down. We're going to break it down with x plus 1 this time. So the question you'll ask yourself, how many times does x go into 6x cubed? Or what do you multiply by to make x become 6x cubed? And be really careful with the minus sign. Like that minus sign has to distribute to all the pieces. So if we have x, we need to multiply it by 6x squared to make it 6x cubed. And if your first term doesn't eliminate, then that's a key that you didn't use the right number. So what do you get when you subtract the first two, Brandon?
Negative 25x.
Nice job. And then bring down the 16x, and then try again. So then we have x. We want to make it negative 25x squared, so we would need to multiply it by negative 25x. Again, be really careful with your signs. Brandon, 16 and 25 give you 41. Bring down the minus 4. There is an x. What do we need to multiply it by to make it 41x? Well, it would be a 41. No, it's not pretty. They don't all work out nicely. So that then becomes 41x plus 41. Did anybody get a remainder of 45? Will of you? Negative. So the sign part is going to be the part that trips you up. Just kind of remembering where that minus sign distributing it through. Brandon?
So because there's a remainder, it is not a factor?
So is it a factor? No, because there is a remainder. So anytime there's a remainder, it's not a factor, and that means the problem doesn't have an x-intercept at negative 1. It still has a point there, but it's just not an x-intercept. It's not a place where it crosses the graph at the x-axis. We would write this solution, f of x equals x plus 1. That's what we divided with. Our answer is 6x squared plus 40, nope, how about minus 25x. And then plus 41. Come on, Apple TV. There we go. And then the remainder just gets tacked on at the end. So you could still, like, plug this in and graph it, and you should get the same graph. Like, the graph doesn't change just because we factored an x plus 1 out. Like, you could put this whole problem in to y equals, and you could put the original one in, and you should still have, like, the one graph right on top of the next. We're just changing the way it's written. We're just factoring something out of it. But anytime there's a remainder, whatever we use to break it down isn't a factor. It's not a true x-intercept. Questions? What do you think?
Time consuming.
Time consuming? Some of them are, some of them aren't. Yeah, it just kind of depends how big is there. So we're going to just work through a couple more examples to get you to feel a little more comfortable.
Are we gonna be divided by trinomials this year?
Trinomials. don't worry, Brandon, I wouldn't leave anything out. You know me, we gotta make sure we cover everything. All right, so the next one is a little different because instead of us just dividing by something that's linear, x minus 2, x plus 1, you're allowed to divide by anything. And yes, it could be 3 terms, it could be 4 terms, it could be 5 terms. It just depends on how big your original polynomial is and what we're trying to break it down into. So we're going to divide. Division can be written separate ways. So it might say, take this and divide it by that, or it could just be written as a division problem with a fraction. So the denominator is our divisor, x cubed minus 1. And then the numerator, if you notice up here on my screen, I have like white spaces there because the numerator goes from x to the 5th and then it skips all the other powers. And combining like terms is so important because you don't want to add an x squared with an x cubed because they can't be added together. So when you have powers that are missing, we are going to fill that missing place with a 0 and that matching power. We'll do that for all of the dividing that we do. Like every piece of the problem is important, even though you're thinking it's just a 0x to the 4th, it really doesn't mean anything. It's kind of like holding its location for us. And then we would have a 0x cubed, a 0x squared, a 0x,
This little Apple TV.
and then a 7. Apparently long division is too much for the Apple TV. There it goes. So anytime there's a piece missing, like even if it had x cubed plus x squared minus 1, like that missing piece of the x needs to be accounted for. So every part has to be accounted for when you're looking at that dividend. And now we divide. So it's okay that it's x cubed here. We're still trying to make it into x to the 5th. So Eris, what would you multiply x cubed by to make it x to the 5th? So if we took x times x cubed minus 1, x times x cubed makes x. There you go. It's just x squared. So we're going to place an x squared on top of the x squared. Big lag time here. And then make sure you're distributing x squared by x cubed. And then x squared times negative 1. And then you subtract. This turns into a plus sign. And then add down, or subtract down, not add down. X to the 5th minus x to the 5th is gone. We have nothing for 0x to the 4th, nothing for 0x cubed. At x squared, we have a 0 plus a 1. Okay. We bring down our next piece, and then you try and divide again. What can you multiply x cubed by to make it x squared? 1 over x, yes. Is that a polynomial? No. How do you know when you're done with division? Michael?
You can't take anything more out.
You can't take anything more out. So with powers, when the power you're trying to divide with is bigger than your remainder, you're done. Because there's no way for us to break down x squared when we're trying to pull out an x cubed. You can't pull out an x cubed. We can't take anything else out. So bringing down the 7, that's our remainder. So once the power becomes bigger in the divisor than what it is in the remainder, you can't divide anymore. So this answer would be, what do we have up top there? X squared. I'm going to write that in front just because it's a single term. And then x cubed minus 1. And then the remainder was x squared plus 7. So I flip-flopped the 2 here, just so that the x squared could go in front.
Good afternoon.
I would like to do the last problem, just so you can see how it works with a trinomial.
Tuesday will be PJ Day. Wednesday is your favorite sports team. Thursday is your favorite character, and Friday is red and white day. Please remember, all outfits should be school appropriate. Your last chance to buy your tickets to homecoming is right now. See Ms. Zimmerman in the Activities and Athletics office before 2 p.m. today. Thank you and have a great weekend.
So just so you can see how it works with a trinomial, you're still only focusing on the first term. It doesn't matter that there are two terms following it. Brandon, if you have an x squared, what would you multiply it by to make it 2x to the fourth?
2x squared.
2x squared. And then you're taking that 2x squared and you're multiplying it with the trinomial, x squared plus 2x minus 3. Don't forget to subtract. So it's really a negative 4x cubed and a positive 6x squared. And then Chelsea, when you add them, what are you left with?
Just an x squared.
Just an x squared. So 2 terms canceled. That means we need to bring down 2 terms. So plus 3x minus 2. Plus we have a trinomial that we're trying to divide into. It has to be another trinomial. Alright, so what do you have here? X squared. We're trying to make it into x squared. What could we multiply x squared by to make it become x squared? Chelsea? Just 1. Because they're the same, you can still divide. So as long as they're the same, we can still do the division because I can just multiply it by a 1. And that would keep it as x squared plus 2x minus 3. So we have a minus 2x and a plus 3. And then when you subtract, 1x plus 1 is our remainder. And when I write my answer, like I usually write the number of terms that are the least to the first. So the quotient has 2 terms in it. That was just the 2x squared plus 1. And then the divisor was x squared plus 2x minus 3. And then the remainder is that 1x plus 1. As long as you have the divisor and the quotient next to each other, the order that they're in does not matter. The remainder has to be that second piece, that extra addition. Questions? It was a lot for a 9th period on a Friday. So in the book, 9 through 21, I believe is 7 problems, maybe it's 8, of the long division to get you to practice through. My temptation was to assign all of them so that you could thoroughly practice them. Because on Tuesday, we're learning a different way to divide. There is no time in this class to do extra practice. Yesterday was a bonus day that we kind of finished up the section and we had extra practice. But the unfortunate part about this class is every day is something new. And there's not a lot of practice time that we have built in because we've got to get to a certain point. So homework tonight, that 9 to 21 odd, some lovely long division problems. Have an awesome 3-day weekend. Don't forget about page 21 in your packet. Questions?